Hello, everyone. Welcome to the third lecture. Today's lecture is on relational databases. So as you remember from Monday, in relational databases, there are three types of relationships. There's a one-to-one, where each entry in a table corresponds to only one entry in another table. A one-to-many, where an entry in one table can correspond to multiple entries in another table. And a many-to-many, where multiple entries in one table correspond to multiple entries in another table. So before we get started with the demo code, we're going to continue what we did on Monday, just working in the SQLite shell. So let's begin by opening up the terminal and launching the SQLite shell using the SQLite 3 command. And what this is going to do is let us directly interact with SQLite databases. So on Monday, we went over one-to-one relationships and one-to-many relationships. So now let's go over many-to-many relationships. And to do that, we are going to create a relationship between posts and hashtags. So the first thing we can do is like recreate the tables that we had from last time. So I'm going to create the user table again. And if you remember, we had an ID of integer primary key. And a name, and that's going to be text not null. And then we also had a profile table. So I'll create a table profile. That table had an ID. It also had a net ID. And that's going to be text not null. And then we related the user table and the profile table with a foreign key. And that was called user ID, which was a unique integer. Okay, now we can create our post table. So if you remember, one user can have many posts. So I'll create a table post, and that's going to have an ID. It'll have a description, and that'll be a text not null. And again, we'll have a foreign key user ID. And this is going to be an integer not null because we have a one-to-many relationship now. Okay, so now to establish a many-to-many relationship, we're going to create a table hashtag, and multiple hashtags can correspond to multiple different posts, and multiple different posts can correspond to multiple different hashtags. So we'll create this table hashtag, and it's going to have an ID. That's going to be our primary key. And a name, and that is going to be text not null. So now if I use the .tables command, I see we have successfully set up our hashtag table, our post table, our profiles table, and our user table. Okay, so if we remember from Monday, to create a many-to-many relationship, we don't use foreign keys. We use something called a join table or an association table, which facilitates the many-to-many relationship. So to create a relationship between a post and an ID, we would basically insert both the post ID and the hashtag ID into a row in this table. So we're going to create this table and we'll call it feed. And it's going to have its own ID and also two foreign key properties to reference the ID of the hashtag and the ID of the post. Okay, so now let's insert some data into our hashtag tables. Let's create a hashtag. So I'll write insert into hashtag and then the column, so name, and the value I want to insert into name will be maybe Cornell. And then I'll create a second hashtag, and maybe this one will be like fitness. And now we can associate these hashtags with posts. So to do that, I have to add back in some posts. So I'll insert a post with columns, description, and user ID. And I'll pass in values of maybe 3110 is easy. And before we do that, we have to create some users as well. So I'll enter into user, maybe me. And then I'll also pass in Daniel as a second user. Okay, now we can create that post and we can have Daniel be the author of that post since he's taking 3110. And maybe we'll create a second post. We can call that intro to backend is great. And we can say that I'm the author of that post. So I'll relate it with my row in the user table, which is row 1. Okay, now we can associate one of those posts with hashtags. So let's say I want to relate Daniel's post about 3110 with Cornell. So I'll write insert into feed. And then for the columns of post ID and hashtag ID, I can pass in the values of 1 and 1. Okay, now if I select all from feed, I see that I get back a list of IDs corresponding with the ID from the feed table, the ID from the hashtag table, the ID from the post table. There are more advanced SQL queries that we can do that would let us retrieve data in a more readable format, but this isn't necessary to know for this class. If you want to learn more about SQL queries, you can take CS 4320 or ORI 3120, where you'll work with more advanced SQL queries. Okay, does anyone have any questions about setting up one-to-one, one-to-many, or many-to-many relationships before we move on to demo code? Okay, so let's get started on the demo code. If you don't already have that downloaded, you can find it on our website under the pre-class to-dos. Okay, so now that we've gone over the different kinds of relationships, we'll build on the foundations that we set in demo 2 to introduce a one-to-many relationship between tasks and their respective subtasks. And this is going to involve creating a new subtask table in our database and linking it to our task table. So if you look at the top of app.py, it's been structured slightly differently than it was before. And we're now handling two different types of responses. We have a success response and a failure response. And this setup is how we're going to maintain consistency and how our application communicates the outcomes of API calls to the client. So the first thing I'm going to do is just set up my virtual environment. So I'll run Python 3 -m then and then I'll activate it. And then I'll install my requirements. Okay, so the first thing we're going to do is define a subtask table in our db.py. And to do that, we're going to need a new function called create subtask table. So I'll define that under this subtask section. And this is going to take in a parameter of self. And for a description, I'll write something like using SQL creates a subtask table. When you submit your assignments, please make sure to document them with documentation that looks like that at the top of every function. So like last week, we'll use the self.con.execute function and pass in our SQL query as a string. So I'll write self.con.execute, and then I'll use a multi-line string. And inside, we're going to create a table subtask. And then remember, we need the if not exists keyword. And then as columns, we'll use ID for our primary key. Each of our subtasks will have a description, and that will be text not null. And a done value, which represents whether or not the subtask has been completed yet, which will be a Boolean not null. And then we need a way to relate our subtask table to our task table. So we'll do that with a foreign key. So I'll write task ID as the name of our foreign key, and that's going to be an integer, not null. And then I'll relate that to our task table. Okay, and we're also going to have to call this function in our init function. So right under our create task table call, I'll also make a call to create subtask table. Next, we need a way to insert tasks into our subtask table. So we'll write that function next. And I'll call that function insert subtask. And that will take in parameters of self and then each of the columns of subtasks. So that'll be description, done, and task ID. And as a description for this function, we'll write using SQL adds a new subtask into the subtask table. So again, we'll call self.con.execute. And we're going to perform an insert query that inserts a subtask with the description, done, and task ID values passed into the function. We'll save the result of that query into a variable called cursor. And then we're going to save these changes in our database by calling self.con.commit. And finally, we'll return cursor.lastRowID, which will contain the ID of the task or subtask we just created. And the next thing we're going to need is a function that gets a subtask by its ID. So again, we call self.con.execute. So I'll write function get subtask by ID, and that takes in a self and also the ID that we want to query for. And as a description, we can write using SQL gets a subtask by its ID. Now I'll write self.con.execute, and we perform a select query that filters tasks by the ID provided as an argument. So the syntax for that is select all from subtask, where ID is equal to the ID that we passed into the function. And the syntax for a single item tuple requires a trailing comma, which is why I put a comma there. And what we want to do now is if a task or a subtask exists, we want to return a dictionary containing the task details. And since there's only one subtask, we know that there can only be one row, so we can directly return the subtask's values. So I'll write for row in cursor. and save the result of our query in a variable cursor. And I'll return the ID as the ID we passed into the function, a description of row 1, a done value of row 2, and a task ID of row 3. And if there is no task found, so in the case that the subtask ID does not exist in the database, the function returns none. Okay. And the last function I'll need to write in my db.py is for getting all subtasks belonging to a particular task. So to do this, I can write a function get subtasks by task ID. And this will take in a parameter of self and ID. And as a description, we can write that using SQL, we'll get a subtask by its task ID. So the logic here will be very similar to getting a subtask by its own ID. So I'll just copy that over. The difference now is that we're going to query for task ID instead of ID. And because now we're returning more than one row of subtasks, we can create an empty subtask array and append each row in cursor to our subtasks array before returning that array. So I'll create an empty subtasks array. And for each row in cursor, instead of just returning it, I will append it to subtasks. And then just return that. So now that we have these functions, we can write endpoints to create and get subtasks in our app.py. I'll write the route to create a task first. So first I'll need to write a new route decorator. And we'll have an endpoint of tasks slash, and then I'll accept an integer, which we'll refer to as task ID. And then subtasks. And our method will be post because we're creating data. Then I'll define a function to run when we hit this endpoint, and I'll call that create subtask. And that's going to take in the task ID from the URL. So in create task, we load the request body and retrieve the description. So I'll write body equal to JSON.loads request.data. And then I'll get the description. Next, we check if our task ID refers to a valid task. And if it doesn't, we want to return an error message that our task was not found. So I'll try and get the task by task ID. And if task is none, or if it doesn't exist, I'll return a failure response saying that our task was not found. Once we've confirmed our task exists, we'll create a new subtask based on the description provided in the request. So I'll call that function we just created, insert subtask, and I'll pass in the description. Our done value, we're going to set to be false at first because we assume that the task isn't done when we create it. And then I'll pass in the task ID. After inserting the task into the database, we'll retrieve the newly created task to make sure that it was successfully added. And if there's an error, the route will return an error message. Otherwise, we'll return the details of the new task. So to do that, I'll create a new variable subtask. And I'll get the subtask by ID using the subtask ID that we just got. And then if subtask is none, we'll return a failure response saying that we could not create a subtask. And we'll pass in a status code of 400. Otherwise, we'll return a success response with the value of subtask and a 201 status code because our resource was successfully created.
I think you spelled boring wrong in the create table.
Oh, thank you. Okay. So now we can do what I just did, which is run our app.py using Python 3 app.py. And we can test the functionality of our route in Postman. So I'll create a new collection and I'll call it demo 3 and a new request. And I'm going to copy over the endpoint that we want to hit. Okay. So that's what we're going to hit. First, we should create a task. So I'll pass in a request body. And to create a task, we're going to need a description. So I'll set the description equal to homework. Okay, so now we've created a task homework, and let's say we want to add a subtask of maybe problem 1. So I'll write the description we want to pass in for that subtask as problem 1. and I'll hit the endpoint we just created. So I'll pass in the ID of the task I want. And I'll write subtasks. I believe we only have, do we have, okay. Okay, so now we have a task, and the subtask is problem 1. It has a done value of false and a task ID of 1. So now that I have some subtasks in my database, let's get all of the subtasks by a task ID. So to do that, I'll go into my app.py and I'll create a new route. First, I'll write our route decorator, and we can use the same endpoint as before. And because we're just getting data, our method will be get, so we don't have to specify that here. Function that we're gonna run when this endpoint is hit. So I'll write get subtasks of task, and I'll pass it task ID for itself. So the logic here is that we first want to get a task by task ID, and if it doesn't exist, we will return a failure response, and if it does, we'll return a dictionary of its subtasks using our get subtasks by task ID function. So first, I'll try to retrieve the task using our get task by ID function and pass the task ID from the URL. If that task is none, or if it doesn't exist, I'll return a failure response saying that the task wasn't found. Otherwise, we'll return a success response, which will contain a Python dictionary, where we'll map subtasks to an array of subtasks. Now let's test this in Postman. So if I change this to get, now I'm getting the list of subtasks for ID1. Okay, and the last thing we're going to do for a demo today is right now, if we were to call the GET request for getting all of our tasks, we wouldn't see any of our subtasks. So we can modify the get all tasks method to return subtasks as well. So in our db.py, we can find our get all tasks function. And I'll just add another row for subtasks and return a call to self.get subtasks of task. For the ID. So lastly, if we now try to get all tasks in Postman, I get back a list of all the tasks in my database along with an array of all their subtasks. Okay, so that's it for demo code today. Now we have a quick Kahoot for you.